This video, we're going to talk about how to use double angle and half angle formulas to find exact values of trigonometric functions from 6.6. I have most of the formulas up here for this. The only one that I don't have on here is that sine of 2x is equal to 2 sine x cosine x, because that's on the sheet of things that need to be memorized. So let's go ahead and work on an example that looks like 6.6.9, number 9 from 6.6. And this is a multi-part problem. It says if sine theta equals 24 over 25, and theta is between 0 and pi over 2, then find the following values. Well, let's draw this triangle here first. That sine is 24 over 25, so this side is 7 by the Pythagorean theorem. Then we want to find first sine 2 theta, which is going to be 2 sine theta cosine theta, which is 2 times 24 over 25 times 7 over 25. And this is going to be 625 for my denominator, and 24 times 14 is 96, and 24 is 336, and there's no common factors because we had it factored there and nothing canceled, so that won't reduce at all. B asks us to find cosine of 2 theta. You've got lots of options here for what that is, but since sine was given to us, let's use the version that has sine in it, which is 1 minus 2 sine squared theta. 1 minus 2 times 24 over 25 squared is going to be 625 over 625 minus 24 times 24 is 576. 2 times that is 12, 15, 11. So 1152 minus 625 is 527. So that's negative 527 over 625. Then C asks us to find sine of theta over 2. We'll have to look at the half angle identities here for sine. So that's the square root of 1 minus cosine of theta over 2. There's a plus or minus out front here, but since I know that theta is in quadrant 1, that theta over 2 is also in quadrant 1, and I'm going to have a positive value for sine. So this is square root of 1 minus, and the cosine value here is 7 over 25 over 2. So let's multiply everything by 25 over 25 to get rid of that fraction. It's going to be 2 times 25 is 50. 25 minus 7 is 18. Let's multiply this by 2 over 2 to get to a perfect square in the denominator. So this is going to be square root of 36 over 100 is 6 over 10 is 3 over 5. Now we want cosine of theta over 2. And cosine of theta over 2 is also going to be positive. It's square root of 1 plus cosine of x over 2. So that's square root of 1 plus 7 over 25 over 2 is square root of 25 plus 7 over 50 is square root of 32 over 50 multiplied by 2 over 2 is square root of 64 over 50. I'm sorry, 64 over 100 is 8 over 10 is 4 over 5. And then we want tan of 2 theta. So tan of 2 theta is right there, 2 tan theta over 1 minus tan theta squared. Okay, so tan of theta is 24 over 7. One minus 24 over 7 squared. So that's going to be 48 over 7. And then this is minus, and then this is divided by, and then this is, let's just work this out separately. 48 over 7 over, this is going to be 49 over 49 minus, and then 24 times 24, that's 96, that's 48, that's 576 over 49, 576 minus 49 is 527. And 7 goes into 49 7 times. 48 times 7, 56. 28 plus 5 is 33. This is 336. Negative over 527. That's negative because of that negative that's in the denominator, and it's positive in the numerator. Positive divided by a negative is a negative. And last but not least, for f, is tan of theta over 2, which we can find a few different ways. Right here, and since we have sine and cosine, let's work on one of the ones that gives us a definite value here. Let's have just the sine in the denominator. So 1 minus cosine over sine minus cosine over sine is 1 minus, and then cosine is going to be 7 over 25. This is going to be 24 over 25. We're going to multiply everything by 25 over 25, and we get 25 minus 7 over 24 is 18 over 24. Both are divisible by 6. That's 3/4. All right. Let's take that all away, and we'll have to remember those formulas for the next one here. So given that cosine of theta equals negative √7 over 3, and that theta is in quadrant 2, find sine 2 theta. So cosine negative √7 over 3, 9 minus 7 is 2. This is √2 here. So sine theta is going to be √2 over 3. Tan theta is going to be negative √2 over √7, or negative √14 over 7. Right? So sine 2 theta is 2 sine theta cosine theta is 2 √2 over 3 times negative √7 over 3 is negative 2 √14 over 9. B is cosine 2 theta. And let's make this cosine squared theta minus sine squared theta to help me. Well, no, let's just, yeah, that'll work. Cosine squared theta minus sine squared theta is cosine squared, that's going to be 7 over 9 minus 2 over 9 is going to be 5 over 9. And C asked me to find sine of theta over 2. So theta over 2 is going to have to be between pi over 4 and pi over 2, which is in the top half of quadrant 1, which is going to have a positive sign value. So that's going to be square root of 1 minus cosine theta over 2. That is 1 minus, and that's √7 over 3 over 2. So that is going to be equal to square root of 3 plus √7 over 6. And I need to, I can leave that just like that for my math lab. Most of the time your teacher will want you to get rid of this denominator here. So you would want to multiply it by the first number that would make a perfect square there, which would be 6, and you'd end up with something like 18 plus 6√7 or something like that. But my math lab is going to be happy with this answer for C, so we'll leave it just like that. For D, we want cosine of theta over 2. Again, we're going to be in the top half of quadrant 1, so it's going to be positive. This is going to be 1 plus cosine of theta over 2. This is going to be 1 minus √7 over 3 over 2. So this is going to be √3 minus √7 over 6, like that. And again, my math lab will be totally happy with that. You can leave it just like that. E is going to ask us once again for tan 2 theta, which is going to be 2 tan theta over 1 minus tan squared theta. Just a second, I think that's right. And so tan theta is let's see here. Let's use this one. 2 times negative root 14 over 7 here, but when I square it, let's do this one. So minus, and when I square this, I get 2/7. So this is negative 2 root 14 over 7 divided by 5 over 7. And that's going to give me negative 2 root 14 over 5. Okay, and then we have F asks us for tan of theta over 2, and we were given, I think we were given cosine. Doesn't really matter. They're both just as ugly as each other in this problem. So tan of theta over 2 is tangent's going to be positive in quadrant 1. Let's stick with this one that has a single fraction down here. 1 minus cosine is, so that's going to be plus root 7 over 3. And sine is going to be root 2 over 3. And we're going to multiply everything by 3 to make this 3 plus root 7 over root 2. We need to multiply by root 2 over root 2 to rationalize the denominator. They don't want that answer. This is going to be an equivalent answer, but they don't want this answer. They want me to use this form, which is fine. I decide that it's going to be positive, and I'm going to use 1 minus cosine of x over 1 plus cosine of x. And that's going to be 1 minus, and then cosine was root 7 over 3. And then 1 plus root 7 over 3. Multiply everything by 3 over 3. Give me root 3 minus root 7 over root 3 plus root 7. And they just want this all in a big root. That's all they wanted you to do, because you can evaluate that in your calculator, so they didn't want you to go any further than that. All right, let's go ahead and remove those. And they're going to tell us that cotangent of theta is -9, and secant of theta is negative, and the angle is between 0 and 2 pi. So we have to think what quadrant we're in. Negative cotangent is going to put us in quadrants 2 or 4. And negative secant value is going to put us in quadrant 2. So let's go ahead and draw our triangle in quadrant 2. Cotangent is adjacent over opposite. So adjacent over opposite like that. Then by the Pythagorean theorem, we have 9 times 9 is 81. 1 plus 1 is 1. Or I'm sorry, 1 times 1 is 1. 81 plus 1 is 82. So square root of 82. That doesn't simplify anymore. That's 2 times 41. No perfect squares in there. So we have sine is 1 over root 82. So root 82 over 82. Cosine is negative 9 over root 82 is negative 9 root 82. Over 82. Tangent is negative 1 over 9. And we'll see if we need any of the other trig functions here in a little bit. And we have sine of 2 theta, once again, which is 2 sine theta cosine theta, which is 2 times root 82 over 82. And that's 41. That's root 82 over 41. And I forgot to multiply by cosine. Cosine is negative 9 over root 82. So that will cancel and leave me with negative 9 over 41. That's what I wanted. And B here is cosine of 2 theta is let's go with the one with sine in it, which is 1 minus 2 sine squared theta. It's 1 minus 2 times 1 over root 82 squared is going to be 82 over 82 minus 2 times 1 over 82. It's actually going to make this 41 over 41. So 41 minus 1 is 40 over 41. Yeah, they didn't reduce that. They left that as 80 over 82, which doesn't make any sense. So reduce your fractions here. So C is sine of theta over 2 is going to be root 1 minus cosine theta over 2. It's going to be root, then 1 minus, and cosine is negative 9 over root 82. So plus 9 over root 82 over 2. So we can make that equal to root, let's multiply by 82 over 82. So that's going to be 82 plus 9 root 82 over 164. And then we have 4 times 41 in the denominator. So that 4 can come out here. Like so. And they're going to call this 1/2 times this. Normally we don't leave square roots in the denominator, but in this assignment they are perfectly happy for you to do so. So let's go ahead and find, if your teacher says otherwise though, you rationalize that denominator. So now we want cosine of theta over 2, which is going to change this to 1 plus cosine of theta over 2, which is going to be 1 minus 9 root 82 over 2. Again, let's multiply by 82 over 82. Root 82 minus 9 root 82 over 164. And again, pull out that 4 there. It's going to be 1/2. Then this is root 41. This is root 82 minus 9 root 82. And they're happy for you to leave it just like that. Let's get E here, which is tan 2 theta, which is 2 tan theta over 1 minus tan squared theta. Tan theta we found to be negative 1/9. So 2 times negative 1/9 over 1 minus negative 1/9 squared is negative 2 over 9 over, and then this is going to be minus 1 over 81. I'm going to make this 81 over 81. It's negative 2/9 divided by 80 over 81 is negative 2/9 times 81 over 80. 9 goes into 81 9 times. 2 goes into 80 4 times is negative 9 over 40. And one more here. F is tan of theta over 2, which they're going to use the definition that is 1 minus cosine of x over 1 plus cosine of x. And I have to figure out that since we are in quadrant 2, theta is actually between pi over 2 and pi. But that means that theta over 2 is between pi over 4 and pi over 2. We're in the top half of quadrant 1 for our half angle. So tangent's going to be positive. tangent of theta over 2 will be positive. So that's square root of 1 minus, and then the cosine value here was negative 9 over root 82. Over 1 plus negative 9 over root 82. So that's going to be multiplied by root 82 over 82 over root 82 is going to be root 82. Let's just make this 82 over 82. 82 plus 9 root 82 over 82 minus 9 root 82. And that's how they want you to leave that answer. So let's finish up the last couple problems here, which I think you'll find to be easier. Sine of 22.5 degrees, clearly a half angle since it's half a degree. 22.5 times 2 is 45. So this is sine of 45 degrees over 2. So we're going to say this is square root of 1 minus cosine of 45 degrees over 2, using the half angle identity for sine. And so that's going to be 1 minus root 2 over 2 over 2. It's going to be, let's multiply everything by 2 over 2 to clear those fractions, is root 2 minus root 2 over 4. Square root of the top and square root of the bottom should leave us with square root of 2 minus the square root of 2, and then all over 2. And then last here, number 5 is going to be to use the half angle formula to find cosine of 165 degrees. So 165 times 2 is 13. So that's cosine of 330 divided by 2. 330 is 30 degrees off of the x-axis down here. That's a negative 1 root 3 2 situation. So this is going to be square root of 1 plus cosine of 330 degrees, all divided by 2. The cosine of 330 is root 3 over 2. Going to multiply here by 2 over 2 is 2 plus root 3 and then over 4. And we're going to split that square root top and bottom like so. And that is it for these problems, and we're all done with our objectives for chapter 6. So we will come back next time and start talking about our objectives from chapter 7. See you for the next video.